I remember looking at it and being like, this is good because it's like real.
Things are just moving so fast that infra engineers haven't even had a chance to catch up.
I'll like throw it to a customer and they'd be like, garbage, garbage, garbage.
Google is just the king of compute.
And I was like, no, don't do that. We're using Gemini 2.5 in production.
You have to sort of now reason about latency and intelligence on the same graph.
It's great to have you guys here. Great, super excited that we made this happen. Today we're going to be talking through instruction following and benchmarks around what are people using as reasoning models behind voice AI. I'm Brooke, I'm the founder of Coval, and we're building simulation and evaluation for voice agents.
I'm Zach. I'm one of the founders and CEO of a company called Ultravox AI. We train real-time speech models.
And I'm Quinn. I'm co-founder of Daily. We make global infrastructure for real-time audio, video, and AI.
What a group. I feel like all of us kind of are looking at the same elephant of voice AI from different angles.
I'm excited to talk to both of you because I turned one of our internal benchmarks we have at Daily into something we could publish because thinking about how different models perform on the hard things about voice AI, instruction following, function calling reliability, kind of turn-taking reliability, is challenging, and we all have kind of tests and vibes that we do, but I wanted to publish something that people could criticize, and try to help make better. And Ultravox did amazingly well on that benchmark. Brooke, what's hard about benchmarking voice AI? Because you've thought a lot about like the whole testing end-to-end challenge in voice AI.
I'm super excited about the benchmarks you published. Benchmarking instruction following is no easy feat. I think instruction following is by far the hardest one to benchmark because of these problems. I also think that there's just like such hunger for this, so I'm really excited to hear like what Zach is hearing in terms of like why they think they did so well on these benchmarks, because this is by far the biggest thing that people are focused on. Is now latency is low enough, interruption rates and being able to do voice activity detection is good enough that people are pretty satisfied with where we are, but that instruction following, especially as you keep trying to do harder and harder types of tasks, is really where people spend a lot of time.
And then Zach, like, how did this thing, how did Ultravox do so well on this really hard 30-turn long context tool calling benchmark?
I thought I was also really excited when I first saw. I remember how I even saw originally that you had published this eval somewhere, Quinn. Maybe you would link to it somewhere, but I remember looking at it and being like, this is good because it's like real. There's so many evals out there, and we publish them as well, things that like Big Bench Audio that measure interesting like logical reasoning puzzles, let's say, and how well do you do over audio. But, and they're all like good proxies for something, like Big Bench Audio is a proxy for speech understanding and how you can compare that to the text-based input method. I'll tell you that I think the number one sort of secret that I found for doing well on these benchmarks is just hacking into Quinn's computer.
You joke, but like there's a lot of benchmark maxing in AI, and one of the challenges of writing good benchmarks, I think, is trying to understand first what the realistic use case is, and second, make the benchmark something that's not just going to map to something that people are benchmark maxing, but really is going to reflect like some part of the hard workloads here.
I think actually what the eval exposes when you look at the end results is there's this really interesting sort of trade-off that's now emerged, I would say, in the model selection space, which is that when you have to sort of now reason about latency and intelligence on the same graph. And I think what your benchmark is really showing is that the frontier is absolutely moving forward. And so I think that that's what's really interesting. Is like, we saw all this explosive growth in sort of model reasoning in 2025, and obviously sort of like thinking modes are going to be a big thing moving forward. But it's not obvious always how it translates into voice AI, which is why I think for a lot of deployments, you continue to see models that are now like a year and a half old, still as the foundation for those systems. And I think when you look at the instruction following and the intelligence, and you're like, well, why isn't it doing very well? Well, it was doing really well probably for a late 2024 era model, but we've made lots of progress, and it's been hard, I think, sometimes to realize that in voice AI because of this sort of like trade-off between intelligence and latency. And I think that's been a tricky thing to navigate. I think that's what your eval does a really great job of kind of demonstrating that the trade-offs that exist there.
I do want to ask, Zach, how you closed that gap, which seemed so hard to work around and close to those of us building voice agents, even 6 months ago, where the open-ended conversational capabilities of the models were so great, and they felt very human-like when you're talking to them. But it was extremely hard to prompt and context engineer them to get the instruction following and the function calling up to production quality. And I remember talking to you after the Llama 4 launch when we were sharing a car ride back to San Francisco and saying, like, I really thought you just had to do a ton of context engineering. And you gently pushed back and said you thought you could solve that at the model level. And I was super skeptical. But I have to say, I think you've solved a big chunk of that at the model level. Is that training data? Is it model architecture? Is it something else? What helped you close that gap?
Well, I think, I candidly, I think some of it's just also building on top of like the really great work that open weight models are now doing. I mean, like, forget about the speech side for just a second. I think that we saw tremendous growth in open weight models. And really, I mean, the credit goes to a lot of the Chinese labs that are really pushing the frontier of open weight models. And so I think they get like a lot of the credit, I think, for helping push a lot of this forward. And I think that and so what I think we do is we sort of take a lot of that and then we build on top of it. And I think what we have been trying to solve at Ultravox is we've long been believers in speech native models and the importance of those architectures for achieving like increasingly again human-like conversations. We've got to remove the ASR step. We've got to remove all these things. And so what we've spent a lot of our time doing is like, okay, how do you add speech as a modality without making the model dumber? And I think it's like, that's actually, I think, an extremely hard problem. And then over the last year and a half, I think solving a lot of interesting model layer and model training challenges for how we can add this speech modality without impacting the reasoning abilities of the model. And I think that it's sort of, and honestly, it all kind of came together at the end of Q4. Ultravox models all throughout 2024 or 2025, but it wasn't until the end of the year in Q4 that I felt like we really had all the pieces put together.
Well, I don't know if you've seen this as well, Brooke, but what we saw is that for a long time, OpenAI was incredibly impressive in their not having a spread between P50 and P90 on GPT-4o latency TTFT. And I was always in awe of the ability of OpenAI to run this like global supercomputer with very tight tolerances. But I think as AI has just grown and there's been so much demand for inference, everybody's had to make different compromises because we really don't see that consistency anymore from any of the text models, including the Gemini models, which also can be very fast, but are no longer always very fast for us in production.
Yeah, and I think I'm definitely betting that Google gets there, though, because Google is just the king of compute. I think that's been their bread and butter for the past 20 years. And so I think just the maturity of these models is so young. I think I was just talking to Scott about this, is just the reliability that they've been able to achieve with DeepGram models, I think is because of just how long they've been working on these models. A lot of that reliability just comes from years and years of fine-tuning and optimizing and getting them to this like hyper optimized state. And I think with AI, a lot of the models, things are just moving so fast that infra engineers haven't even had a chance to catch up.
And demand is what it is. I mean, you have to make choices about how you handle having too much demand. Google was really public with that when the Gemini 3 launch happened. They had to take TPUs away from Gemini 2.5 and give them to Gemini 3 for the launch. And I was like, no, don't do that. We're using Gemini 2.5 in production. But, it's a good problem to have.
I think it's interesting because doing evaluations of foundational models is so different than doing evaluations of applications and very task-oriented agents. You're going to have I think you're just looking for a much broader array of different things that your model can do. And so what's in distribution versus what's not in distribution, like how does it feel across like all of these different use cases, like ultimately is just a very different problem than setting up evals. And we primarily focus on agent evals. So that was not like a trick question of this is what you should or shouldn't be doing. I think we definitely don't work as much in that space of how do you do model evals versus task evals, which is why I was genuinely curious. I think that it's a much harder problem is to know, like, what are people even going to be using this for? Like, what do people expect from a model? And I think that's where, like, listening to customers, like, when people say, I think some of the best insights we get around what models are doing and doing well is actually just from customers saying, we're hearing jitters, or we're hearing, like we're seeing a lot of markdown in these cases, or we're seeing it vocalizing punctuation in weird ways. Like that's ultimately just what you're going to hear from users, and it's hard to have said like I'm going to create evals for what happens, like how to get it accidentally just be speaking in Japanese. Like how did you even get there? Like, and ultimately listening to users on that front.
Yeah, I'll just add that, like, I do think what sometimes funny things that we run into is we have, like, this set of evals that we always track very closely for, like, at the model. It's like almost like on a model training run gets done, it goes and runs the evals, right? These are things like the big bench audios. These are like Covos 2, which is like blue. So we basically use translation as a proxy. So, if you basically, the model says something in one language and the job is to translate to another. And again, the premise is that if you don't understand what was being said, then clearly you're going to be bad at translating. So I think a lot of these evals in model land are like proxies for the real thing, right? We're trying to proxy speech understanding, and then what's funny is like, but sometimes they can be quite distant from the real world. I'll give you like a simple example is none of these evals, like a really common use case for, I would say, voice agents are things like collection of some kind of data. Let's say like an ID number or a phone number. And what's interesting is these are almost never in the core model speech understanding eval sets for the most part. But they're very common in voice agents. And it's like a pretty hard problem actually, because like you have lots of variations, so they're kind of out of distribution and stuff like that. And so we'll sort of like give ourselves a high five on some of these sort of model performance evals, like look at us improving our blue score. And then I'll like throw it to a customer and they'll be like garbage, garbage, garbage. And you're like, oh yeah, okay, there's a gap in our methodology here. And so we've had to constantly sort of like figure out how to bring those customer ones like also like into the model evals that the modeling team can also, but we weren't good at this at the beginning. Like we would be like, look at us hill climbing this benchmark that someone has set out, but we sort of be missing the fact that there's a whole applied part over here that we're actually not very good at.
Zach, what do you think is still missing from benchmarks? Like, what do you think is not captured? I know that probably naturalness is a big piece of that, but like, what do you think? What are some of the like specifics of things that you think are still not captured in the benchmarks?
I feel like the benchmarks today are actually feel fairly decent for like this like where the models are at presently. I think that sort of happens like there are so many obvious things to me that the voice AI is really bad at. When you said just a moment ago about like it's off by just a beat, and like one of my inner tests, I think, for when I'll know that we've achieved sort of human level voice AI is when they backchannel perfectly. Because backchannels are a great example of like they're either exactly correct and on the mark or they're awkward. And any attempt to try and every attempt to backchannel as a system level thing to me has failed catastrophically. They just are awkward. And it's like, so it's like these small things like this are like this proxy to me. And I don't think we have any evals for this. I don't think we have any evals that are good at capturing the nuances of the conversation. Does the make sense in the right contextual moment? I think another great example of a thing that we have just no good evals at all is we mistake prosody for actually a reasonable response to what the user said. And so I'll give you an example is I would say when you're dialoguing with another human, like the way I'm talking changes the way that you respond back, right? So for example, so if I say a thing in a particular tone, right, and that the interpretation of that tone will change the way you generate text on the other side, right? Or change your prosody dynamically from that. Like my anger induces your anger, or maybe slows it down. We have no mechanisms to measure for any of this. So I think this is like, there's this very long tail of interesting problems that I think, because we don't know how to model it, we haven't really bothered with the eval side, which kind of makes sense, I think. And it's only like, as we climb up the hill, but now I think we're starting to solve kind of some of the speech understanding problems, some of the other things. I think 2026 is the year of trying to tackle some of these things. And so I think we're going to need brand new evals that just right now do not capture at all, I think, some of the things where if you were to give it to a human, why does it feel wrong? And I think you're right. You had a great word. Like putting words to things actually sometimes is really difficult to describe. Like, why is that awkward? Is sometimes, I think, a really hard thing to do.
Yeah, totally. And I think that's exactly where, especially if you're on the frontier of these models, figuring out whether we what are we even trying to do? What's even possible? Like, what does it feel like to be speaking to these models? Like, the human existence can't be captured in like test-driven development, and I don't think that's like even the purpose of evals. I think the purpose of evals is like, how can you quantify something that was working or should be working, and use that as a communication way of being very discrete, especially at scale. But when you're just trying to figure out, can this thing do it one time, is a very different problem than can it do it 10 million times. And so I think, especially when you're like where you guys are at, of like really operating of like what's the like next frontier of what these models can do. I think first figuring that out and then taking that and distilling it and saying, okay, how do we preserve that capability while also continuing to push that frontier?
What do you think, Quinn? You have any parting thoughts for us?
Yeah, I mean, I think it's really exciting how you've put the pieces together, Zach, to kind of get us another level of, fast, smart model. And it's the first speech-to-speech model that I feel like really does compete head-to-head against the transcription LLM voice generation 3-layer stack. So that's super exciting. And I totally agree with Brooke that figuring out like how to build a good cross-model benchmark and then really good application-specific massive simulation evals feels like the next unlock that those of us at the kind of framework level can keep working on in 2026.
Yeah, and I think also one of my big takeaways is like share the problems that you're having with your vendors, because everyone is like trying to figure it out right now, and I think that's our biggest learning is like when we hear people's problems. I think I'm going to go ahead and speak on behalf of both of you, that like hearing from users of what's working and what's not is some of the biggest signal above all else, is like what are people trying to do in production, what's working, what's not, and like we learn so much from our customers.